Okay, let's begin. So we have to make a table of values today. A table of values is simply this. It's sometimes called an X or Y chart because what's at the top? X and Y. Okay, so what you're going to notice is we have a dependent and an independent variable. So independent is going to be X, always is. Whereas Y is our dependent variable. It's the one that we're going to measure. So often it's going to be a distance like meters or centimeters, or it's going to be a temperature. Okay. And use your independent is often for science time. Well, it is, time's always independent. Okay. But sometimes it's time, sometimes it's altitude, depending on the graph. All right. So that's the first little bit of information, dependent and independent. Then we talk about data. What kind of information do those numbers represent? If it's discrete, that means we're talking about whole numbers. Example, people. Example, milk jugs. When you walk into Superstore, you can buy 1 gallon milk, 2 gallons of milk, 3 gallons, right? Those big 4-liter jugs. You can't go in there, open it up, dump half of it out, and go up to the till. Probably have your head bouncing off a police car, right? It won't go well for you. You can get a smaller size, definitely, but then you're buying 1 jug, 2 jugs, 3 jugs, whole numbers, okay? Where continuous data is different. It's reasonable that there's points in between, okay, the data. The data is continuous. So, for example, meters. If you have 1 meter, you can then have 1.01, 1.02, 1.03, ... all the way up to 2 meters. It makes sense, okay? So you got to be careful. Can't get something that's halved. That would be discrete data, okay? Any questions? Now, even sometimes for discrete data, we do connect the dots if we have super large numbers. You know, if we're buying like hundreds of jugs of milk, in between 100 and 200, there is 101, 102, 103, 104. Okay, so that would make sense to connect the dots, sorry. So, for continuous data, we can interpolate and extrapolate. Interpolate is in between plotted points. Extrapolate is after plotted points, or they're basically extra points. So this here is an example of extrapolate. Here we have to extend the line. And so then we could figure out, well, how many years would it take the price to reach $80? So we take a ruler, draw a straight line all the way across until we hit this line, and then go all the way down in a straight line until we hit the other axis. And it would take how many years? 5. Okay, and that's extrapolating. So we can find a value using an extended line. Whereas interpolate, you don't have to extend the line. You're just finding values in between. So we could say, well, at 2.5 minutes, what would be the temperature? And so you draw up to the line and over. And you'd say it would be approximately 3.5 degrees Celsius. Or you could say, how many minutes would it take to reach 4.5 degrees? So what would you do for 4.5 degrees? You would take your ruler, go at 4.5 degrees, and draw a line over, and then draw a line down. So to reach a temperature of 4.5 degrees would take approximately 3.5 minutes. Okay. So the approximate line, that's a squiggly S. Okay. Approximately 3.5 minutes. Any questions? I have a question for you. At 4 years, what's the approximate price? Draw a line up to your graph line, a straight line over using a ruler. 4 years. It's approximately $70. Okay, and from our graph, I'd say it's a pretty good approximation. In fact, I'd be so sure to say it is $70. Okay. Any questions about that? Okay, so I want you now to answer these questions. Here we have an airplane. Looking at your graph, it's altitude and time. From our graph, please explain the situation that's being graphed. Look at the graph, what's the situation? Maharka? No, not at all. That would look something like this. Close though. Next, okay.
How fast it lands.
How fast it lands. Yep, that's kind of getting on the right. So the big thing is you got to recognize we're starting at 20 kilometers in the air at time 0. And the plane is going down in altitude. And right here, what's happening? It's landing. Okay. So you have to be careful on how we graph things. Good. Okay, so answer those questions, please, A, B, and C. Go. 50 seconds is here. Draw a straight line up, straight line over, and what would you say? Approximately 10 kilometers. And from your graph, it's pretty close to right on, I'd say. Okay? You could maybe put 11 kilometers, but looks more like 10 if you had a ruler. What about 11 kilometers? What would you say? Straight line over and down. What would you say? Would 40 be marked incorrect? Absolutely. It's definitely not 40. So I would say approximately 41, maybe 42 I'd take. Okay, and that would be seconds. Okay. Is it appropriate to join the point to the straight line? Why? Yep.
Yes, because the plane is continually going down.
That's right. It's continuous data. Oops, how do you spell continuous, folks? U-O-U-S. Continuous data. Okay. The plane's altitude is gradually decreasing. Imagine if it was discrete data. This is what that would look like. The plane's flying along and then instantaneously drops 1 kilometer. Instantaneously drops another kilometer. Instantaneously drops. You would be dead. Well, probably about half of you would be dead right there from an instantaneous drop, because you would fly up and hit the ceiling and then smash down on the floor once you stopped like that. Right? So that doesn't happen. What happens is the plane comes in slowly to land. All right? Well, it doesn't come in slowly, but it goes down gradually. It's not instantaneous. Okay? So if it was this, here you would be dead. Serious injuries. Okay? Any questions? All right. Next, please look at the graph. Here is an example of extrapolating, because we have to extend our line. So you take your ruler and you extend the line down. Now I'm going to make it blue. Okay. So now answer those questions. Go. Approximate, does it have no value? About 5.1 years. Or you should say after 5 years. Is 5 years the correct answer? Not on mine, because it clearly looks like it's after 5. But if yours is touching it because your line's thicker, then go ahead, you can say that, okay? For some people, I think it does work out, okay? What is a computer worth approximately $200? So here's 200, go over and down. You can say approximately 4 years. Is it appropriate to join the points of the straight line? Yes, because value, which is dollars, is continuous data. Which means that there's points in between, right? Decimal points. Okay, and money's always like that. Money is always continuous because of the decimals. Any questions? Okay. So a couple things with your graph. Don't make it, but you should have a title. Write that down. Title. Write down title. Okay, we're not going to do the graph. We don't have time. And we're going to take away the science type graphs. We're just going to focus on regular graphs. Temperature, degrees Celsius. Units should be in brackets. Altitude is in meters, and meters should be in brackets. Okay. Now to figure out what you should make your increments, for altitude, I have a total value of 1800, and there's 31 squares. So if you divide that, you get 58. So 58 meters per square. That'd be really weird, right? So I go 58, 116. I'm not sure what next, so don't use 58. Okay, 100, way easier to graph. So you got to pick a bigger number that makes it easy. Going up or down for temperature, you're going from 11 to, or 12 to negative 10. So that one has a difference of 22. Okay, so 22 over 19, because there's 19 squares, means you should be at 1.15 degrees Celsius per square. So that you should use 2 degrees Celsius per square going up. And so you can see here's 0, I went down to negative 10 and up by 2s. Okay, so you got to get some values. Now we're going to kind of leave these and come back to them later. Okay, so don't be concerned about that. What you need to do is you need to do two things. Worksheet graphing. You need to do textbook work. Junsberger and Zorna. And we're going to go over that second on a separate sheet of paper, okay? So please take out a new sheet of paper, and we're going to talk about Zorna and the other one. Okay, so what we're going to do is we're going to be graphing using a table of values. Now the focus on today is filling out the table of values and getting used to doing the math, and then plotting the points and making your line. So the first line we're going to plot is y equals negative 2x plus 3. So for our independent values of x, we're going to use negative 2, negative 1, 0, 1, and 2. Okay. So now you're going to have to do some quick math to figure out the y value. So we get -2, and we substitute in for x using brackets, so very important. And we get y equals -4 plus 3, y equals -1. And so that is now our y value, -1. So we take our x value, substitute in, solve for y. Substitute, solve. -2 times, whoa, +4, you guys. I can't believe you got that wrong. That's 7. Whew, good thing I stopped you there, eh? Okay. Good. Next one. So now you're going to get y equals -1, sorry, -2 times -1 plus 3. So x has changed. Find your new y value. And you should get y equals 5. Do the next one yourself. Go ahead. What'd you get? 3? Good, that's correct. Okay. Do the next two. Go ahead. Noah, what's the next one? 1 is correct. Okay. Sigmund, what's the next one? -1, that's correct. Now, because I chose some easy values for x, you saw a pattern for y. What's the pattern? Yeah, it's changing by -2 each time. Do you see that somewhere in your equation? Yeah, right in front of x. So that's called the rate of change. Okay, now only if you're in specific patterns do you see that. Okay, you're not going to see that for a lot of your work, but sometimes you will. Okay? Good. So let's do one more. Let's do 2y plus 3x equals 6. -2, -1, 0, 1, and 2. Now they'll tell you to use different numbers in the worksheet, which is good. Just use whatever numbers they tell you to. Please now do your math, find your y. It should be -2, by the way. -2, -1, 0, 1, 2. Go ahead, do your math. Show it work. So y equals 6 for the first value. This one's a little bit harder. You might want to show your work for all the points. What is 9 over 2 equals a decimal? 4.5. Okay. Any questions? So now what you want to do is you want to graph this. So we're going to graph the points, and the points are going to show us something. So this is what I want you to do. Use a ruler, make a grid. Okay. And now what you want to do is you want to make a grid. So use your lines as a reference point. Don't draw all the lines, just use the ones that you need to count with on your axes. So don't actually make a full complete grid. You'll get graph paper for your homework, but for now you want to practice doing this. Go in between the line, on the line, in between, on, in between, on. Each one is a value of 1. Okay. So now you have an approximate grid. Left to right, try and keep them equal spaced, equal distance apart. So plot the points, please. Okay. So -1, -5, sorry, -2, -7. -1, -5. 0, 3. 1, 1. Yeah, I told you they're wrong, you see. I caught myself there at that one point. So -2, 2, 4, 6, 7. -1, 5. 0, 3. 1, 1. 2, -1. So what kind of pattern do you guys see now after you plotted your points? What are the points making?
Line.
Straight line. Now we found only whole numbers, but it makes sense to have numbers in between if we started calculating decimals. So what we're going to do then, and what if we went further to the left? What about all these points over here and all those points over there for x? Do you think the pattern should continue? Yeah. The pattern should continue forever and ever 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 and ever. How are we going to show that? Arrows one way, but there's a better way, because arrows you'll get questions wrong for grade 10 because it's too short. Well, what you want to do is make your line from one side of the grid all the way to the other side so it touches the top, both sides of the grid. If it stretches all the way across and touches the sides, that's showing that it's going forever and ever. So the line should touch the sides. All right. Now we should also label this. This line is of the equation y equals -2x plus 3. Yep.
Can you write it on the line?
Yeah, you could. Just try and keep it out of the graph, because it just blocks it up a bit. So we usually write it on the edges. Okay. Now, if you had the number 1, you could just put number 1 there. Right? You wouldn't have to write the whole equation. Or if it was graph A, you could line A, you could put an A beside it. Okay. All right, do the next one. Graph the next one. Go. Okay, so let's get going here. -2, 6. That's going to be up where? Right next to it. -1 and 4.5. 1, 2, 3, 4. 4.5 is right here. Good. 0, 3. Oh, they cross right there. That would be an answer to a system. Grade 10. 1, 1.5 would be right here. They're not really touching there. It's a fake point. And 2, 0 right there. So using this one here, we'll use this line and we'll go to different color, blue, orange, no. Good. And so then you can say what? 2x plus 3y? 2y plus 3x equals 6. Okay, so there you have your two lines. Any questions? So part of your homework is page 216. For 216, there's some questions to omit, and we did make that change. The other questions, what you're going to do is worksheet. No, we want worksheets graphing. Jensberger you have to do and fill out. Pretty quick and easy. And then you have to do this one right here, the Zorna. And you have to graph that one. I'll be handing out this graph paper. You have to graph it on there. So question 1 will be on graph 1. Question 2 will be on graph 2. Question 3 on. Oh, you guys are brilliant. You must be in honors or something. Oh, yeah, you are. Okay.